So here we're given this integer v that is greater than 1, and we're also told that it's a square of some integer, meaning it has this form where k is some integer. And it's asking which of the following numbers must also be the square of an integer, and I need to go through all the choices. And a is 81 times v, and if I replace it with this form, it becomes 81k square, and 81 is 9 square, so it is square of 9k, so a works. If we look at b, it is this expression, 25 times v plus 10 root v plus 1. So it's kind of hiding an identity, and I want to see if I can factor this. So this would be 5v square plus 2 times 5 times square root of v plus 1. So I'm trying to write it analogous to a squared plus 2ab plus b squared. So here I have to see, yeah, I actually have to merge these two. So a is 5 root v. So this is really the square of 5 root v plus 1 square. And if you do the expansion, you're going to find that it's indeed 10 root v plus 1. So I know that v is a square of an integer, so this entire expression becomes 5k plus 1 square. And the original question was, is this a square of an integer under all circumstances? And we know 5k plus 1 is an integer, and this expression is a square of an integer. Let's look at c, which is 4v squared plus 4 root v plus 1. So similar to the previous one, this is the square of 2 root v plus 1. And let me check this by expansion. This becomes 4v, actually. No, this one doesn't. So this is actually incorrect. So let me try it again. It's 4v squared plus 4 root v plus 1. So I'm actually going to try it a little bit different. V is k square. Just replace it. 4 times k to the 4 plus 4k plus 1. Is that a square of an integer? And I can try a value. For example, k could be 2. So in that case, v is 4. So this becomes 16 here, plus 4 times 2 plus 1. That's 64 plus 8 plus 1, which is 73, which is clearly not the square of an integer. So C is out. The other approach, what I did here was using numbers, and we can also do that for the other two choices. I think especially for B, which is a difficult expression which some students may not be able to see that it's a square of an integer. And the way you would have to do is to say, let's say V is 4. You substitute that here, so it's 25 times 4 plus 10 times square root of 4, which is 2, plus 1, which is 100, plus 20, plus 1, which is 121, which is indeed square of 11. Now, one example is, of course, sometimes it's not enough. You may want to try another one. Let's say you try V is 9, so that would be 25 times 9 plus 10 times square root of 9, which is 3, plus 1. 25 times 9 is 225, plus 30, plus 1, which is 255, plus 1, 256, and that's square of 16. So here, two examples are indicating that B is going to work as well. So if you're not able to recognize that form, then using those examples would work. So to recap, the correct answers are both A and B statements.